All right, so we are back. Section 4. Section 4 talks about domain and range and inverse functions. So we're going to kind of knock that out. So here we go. Number 1 says find the domain and range, and we got 3 questions on this one. So let's start with the domain. The domain means all of the x values, and so what you need to remember with the domain is that we cannot have 0 as a denominator. So if I just look at the bottom here, okay, and this is my domain work, so I'm gonna create a little space. I know that 2 minus x cannot equal 0. So if I bring the 2 over there, I know that negative x is negative 2, which means that positive x is 2, which means that x cannot equal 2. And you can really think about that. If you put a 2 in there, 2 minus 2 makes 0, and we can't have 0 on the denominator. So that is your domain right there, is that x cannot equal 2. We'll go over here for the range. Okay, so for the range, I'm going to call the range a. It can be any variable, so don't get confused by why it's a. And so what you want to do is you want to set the function equal to a and then isolate x. So if I multiply both sides by 2 minus x, and I think of this as like a binomial, like that, this 2 minus x cancels out, which gives me 3 equals a times 2 minus x. I'm going to divide by a on both sides, which cancels, which gives me 3 over a equals 2 minus x, which, just for all intensive purposes, if this was a positive x, I would move the 2 over and be done. But because it's a negative x and I want it to be a positive x, I'm actually going to move the x over here, which makes it a positive x. And I'm going to move the 3 over a over here, which makes it 2 minus 3 over a. So there's my function right there when I isolate x. And now, just like I looked up here at the denominator of x, now I'm going to look at my a. And what can a not be? A cannot be 0, which means that my range is that f of x, otherwise known as y, cannot equal 0. So domain cannot equal 2 and range cannot equal 0. Okay, part B. So for my domain, I know that radicals can never be negative, just like I know that denominators can never be 0. That led me to do this. Now I know that this part cannot be 0 or cannot be negative, so I know that x minus 5 has to be greater than or equal to 0. So if I move the 5 over, x is greater than or equal to 0. That's your domain. Just like that. And then for the range, it's really just thinking, you know, if my lowest number is 0, I'm so sorry. Bring that over, that should be positive 5. It's early in the morning, kids, I'm filming. X cannot be greater than or equal to positive 5. So if I know that my lowest value or my lowest input is 5, if I put a 5 in there, 5 minus 5 is 0. The square root of 0 is 0, so I know that my range is going to be greater than or equal to 0. That's the lowest square root value you can have. So it's also in knowing the properties of each of these. You know, fractions can't have denominators of 0. Square roots have to always be positive. Things like that. And then my third one is f of x equals 3 plus x minus 2 squared. Well, that's the same as x minus 2 squared plus 3. I just kind of put the plus 3 at the back there. And so with my domain, I don't have any restrictions. You know, this is a quadratic function. There's no restrictions into what you can put into a quadratic function. So my domain is all real numbers, sometimes shown like that. And then when I think about my range, well, I'm going to think about what does a quadratic look like. It's a parabola, and this is in the form of ax minus h squared plus k, where h and k make my vertex. So my vertex is positive 2, positive 3. So positive 2 this way, positive 3 right there. And because your a right here is this imaginary 1, that means it opens upward, which means that right here, if I drag that across, that was at 3. That means that all of my y values, my range values, are 3 and up, which means that it will be greater than or equal to 3. So just kind of looking at some of the things that we know about each function. Okay, think about that. If you have any questions, let me know. I'm going to pause this to write the next one, so to save a couple seconds. I'll be right. All right, question 2 says to find the inverse. So for the inverse, we know that f of x is just a fancy way of saying y. What we want to do is we want to switch the x and the y. So this is actually, instead of becoming y equals x minus 3, is going to be x equals y minus 3, and then we just isolate the y. So if I bring this minus 3 over, I get y equals x plus 3, which now I have that isolated, which means the inverse, f negative 1 of x, inverse means negative 1, is x plus 3. Pretty simple. Okay, B says that f of x equals x to the 5th minus 3. So this is a fancy way of saying y. So that's, instead of y equals, it's going to be x equals y to the 5th minus 3. So I'm going to bring this minus 3 over, which gives me x plus 3 equals y to the 5th. And then to get rid of y to the 5th, I have to take the 5th root, which means I have to take the 5th root right there. That 5th root gets rid of the 5, leaving y, and I get the 5th root of x plus 3. So f to the negative 1 of x is the 5th root of x plus 3. So inverses, switch the x and the y, solve for y. All right, back for number 3. It identifies that the function h of x is x squared and that g of x is 2 minus x. Don't know why I have that, so just ignore that parentheses there. And so we want to find hg of x. hg of x means h, and then we know that g of x is x squared, so I can replace g of x with x squared. And that means, nope, again, it's the morning, it's the morning. G of x is right here is 2 minus x. So that means that I want to take 2 minus x and put it into the h function for x. So this is my h function, which is x squared, but I'm going to replace x with 2 minus x. So instead of being x squared, it's going to be h of x equals, well, I'll just write that x squared. We're going to replace that with 2 minus x squared like that. Okay, so I could say that h of g of x is 2 minus x squared, or I could potentially FOIL that out a little bit by writing it twice, and that would be 4 minus 4x plus x squared, which if I rewrite in standard form would look like that. And so h of g of x is x squared minus 4x plus 4. Now, g of h of x means g, and then we're going to substitute what h of x is. H of x is x squared. Well, if I know that g of x is 2 minus x, I'm just going to substitute x squared in for x, which will give me 2 minus x squared, like that. And there's no simplifying we can do for that, so that is what g h of x is. Okay, I'm going to pause it and then rewrite the next one. All right, part B on number 3 says h of x is square root of 6x minus 1, g of x is x plus 1, and k of x is 1 over x. Now we got 3 different things to do. They get progressively harder as we go. So we'll start with this one. hg of x means h, and then g of x is x plus 1. So that means we're going to take x plus 1 and put it into the x value of the h function, so right there. So instead of 6 and then x, it's going to be 6 x plus 1, then I got a minus 1 back here, all under a radical, which if I square root would be 6x plus 6 minus 1. So I distributed, combine like terms, and I get 6x plus 5. So hg of x, this one, is that. Square root of 6x plus 5. Now the next one says h g k of x. So that's going to be h g k, and then k of x right here is 1 over x. So we work inside out. So that means I'm going to put 1 over x into the g function for the x. So that 1 over x, if I put it right in there for x, would be 1 over x plus 1. So that would be h 1 over x plus 1. And now we're going to put 1 over x plus 1 into the h function, which would be 6, square root 6, 1 over x plus 1 minus 1. Which if I distribute would be 6 over x plus 6, 6 over x plus 6 minus 1, which would be 6 over x plus 5, which, if I kind of combine that, I'll go over here, 6 over x plus 5. If I want that to have a common denominator, I can put x over x. So now they both have a common, because if you cancel these, I still have 5. But now I have a common denominator, so I have 6 plus 5x. So right there, that's 6 plus 5x over x. And that is h of g of x. Now, last but not least, we have, it wants k of g of h of x. So that's k of g, h of x at the top is the square root of 6x minus 1. So we're going to put square root of 6x minus 1 into g. Remember, g was x plus 1. So if I put that in there, that'll be the square root of 6x minus 1 plus 1, separate. So that's k of the square root of 6x minus 1 plus 1. Now we're going to put that into the k equation, which is 1 over x. So 1 over, we're going to replace this into x, the square root of 6x minus 1 plus 1, like that. And then we're going to simplify. So to simplify that, remember, we have to multiply by the inverse. So if I do that, that's basically, it's like this is a binomial. This is one term plus 1, so I'm going to multiply it by 6x minus 1 instead of plus 1, minus 1. Because we cannot have radicals on the bottom, if you remember that. So, pretty easy. 1 times all of that. Anything times 1 is itself. So on top, we're going to have 6x minus 1 minus 1 still, just like that. But on the bottom, radical 6x minus 1 times radical 6x minus 1 gets rid of the radical, which is just 6x minus 1. Radical 6x minus 1 times negative 1 is negative radical 6x minus 1. Positive 1 times 6x minus 1 is positive 6x minus 1 radical. So that cancels. That's what this does by multiplying by the inverse. So that's gone. And then positive 1 times negative 1 is negative 1, which we can then combine these like terms to end up with 6x minus 1 over 6x minus 2. And that is k of g of h of x. K of g of h of x. That was a doozy. Remember, you cannot have radicals on your denominator, so to get rid of them, that's what you got to do. You got to multiply by the opposite. So if it's plus 1, it's the same thing minus 1. If this was minus 1, it'd be the same thing plus 1. And that's going to cancel out those middles and get rid of that radical. All right, last one, number 4. Find the domain and range. And I'm going to go ahead and just pre-warn you that this one is special. So hopefully you can follow along, and we'll see what we can do. So let's start with the domain. Remember, the domain is your x values. They can be almost any number unless you have restrictions. Here we have a fraction, so we can't have 0 on the bottom. So I'm gonna find out what makes 0 down here by taking radical 23 plus 1 over 6x and setting it equal to 0. So if I bring radical 23 over, that gives me 1 over 6x equals negative radical 23. If I multiply both sides by 6, that cancels out these, giving me x. And then 6 times negative radical 23 is just negative 6 radical 23. So that is what would equal 0. So that is what x cannot be. That is your domain. So your domain is every number except for negative 6 radical 23. Now, to find the range, if you remember, from question number 1, I believe it was, we're going to set this equal to a. A is not special, it could be any variable. And then we're going to isolate the x. So, first thing I want to do is I'm going to multiply both sides by this bottom. So if I multiply by radical 23 plus 1 6x, that cancels, and it basically brings it right over here. So I'd have radical 23, a times radical 23 plus 1 over 6x. I'm then going to, so I'll rewrite that. So that's 2 over 7 minus 5.7x equals a times radical 23 plus 1 over 6x. I'm then going to divide by a on both sides, which will cancel it here. And then I'm going to kind of rewrite this like one way there and one way there. So 2 over 7 divided by a is just 2 over 7a minus 5.7x over a equals radical 23 plus 1 over 6x. In order for me to isolate x, I've got to move this x over to join this x, and then I'll factor out an x. So what I'm going to do now is I'm going to move this whole fraction that way and move the radical 23 that way, which is going to give me 2 over 7a. That's a positive, so it's now negative radical 23 equals 1 over 6x. That's a negative, so now it's a plus 5.7 over ax. And I just put that x behind it. It's the same thing. So now that you have your x's, I can factor out an x, which will give me x times 1 over 6 plus 5.7 over a. So I just basically factored out those x's. Now I'm going to divide by this whole thing. So let's just pretend I write it. That'll cancel. And then I'm going to have it over here, which will be 1 over 6 plus 5.7 over a. So now we've got x equals, I just wrote it on this side, all of this, which is 2 over 7 minus radical 23 over 1 over 6 plus 5.7 over a. Now remember, this is a fraction, so we cannot have the bottom equal to 0. So now I'm going to take 1 over 6 plus 5.7 over a, set it equal to 0. Bring that over, which is going to be 5.7 over a equals negative 1 over 6. Multiply both sides by a. Cancel, cancel. So 5.7 equals negative 1 over 6a. Multiply both sides by negative 6. That negative 6 cancels out the fraction. A, and then negative 6 times 5.7, 30 something, 34.2. I'm typing it into my calculator. 6 times 5.7, 34.2. So negative 34.2. So remember, that's what would go on the bottom to make a 0 here, so it cannot be that, which means that your range, we call f of x, cannot be negative 34.2. All right, that is section 4. I will keep going with more and update the pacing calendar. Just let me know if you guys have any questions, and good luck.